Hello everyone. Today we're gonna start talking about uh, polynomial problems, polynomial algorithm, and also non-deterministic polynomial algorithm. So let us start first with some functions, okay, that we already know that they are polynomial. So we have the function n, we have n squared, and also like the n log n. Okay, there are some polynomial like time complexities. And you may ask that why n log n can be like counted as a polynomial time complexity. And the reason is we're gonna like see the definition first, that what's gonna be the polynomial time complexity for a function. So that this is the definition, that is for a given input size n. So for a given input size n, there exists a polynomial function, let's call it Pn, such that the worst time complexity of the algorithm, okay, is from the big O notation of Pn. So that's a definition for like a polynomial time complexity, that in the worst case, okay, for a for an algorithm that for a problem that with size input size n, then the worst time complexity is from the big O notation Pn. So definitely n is from big O notation of n. N squared is from the big O notation of n squared, and also we can say that n log n also is from the big O notation of n squared. So the worst case, let's say that is n log n, and it is from the big O notation of n squared. So that's why we are saying that n log n is also a polynomial time complexity for an algorithm. On the other hand, we're going to see some of the functions that are not polynomial. For example, we have the function 2 to the power n, or we have 2 to the radical n, or we have the n factorial. Okay, you may say that, for example, n factorial is less than n to the power n, but n to the power n is not a polynomial function. Okay, so that's why like the definition of the polynomial functions, and we had some example of functions that are not polynomial. So with this definition, we're gonna have another definition of problems that are intractable. So let's define intractable problems. Intractable problems are those problems that it is impossible to solve them with a polynomial time algorithm. Okay, so keep it in mind. It's really important, to have it in your mind that when we're talking about intractable problems, it doesn't mean that we couldn't find we are not talking about the algorithm. We're talking about the problem itself. Okay, so for example, it might be possible. For example, you are finding an algorithm or writing an algorithm for search algorithm or sorting algorithm that is not polynomial. But it doesn't mean that the search problem or the sort problem they are not polynomial time. It doesn't mean they are intractable. They are non-intractable because the problem itself, as we showed before, we can have some polynomial time algorithm for them. So it's about the problem. and not the algorithm itself. Although we might not have been able to find some algorithm in a polynomial time for some functions, again, it doesn't mean that they are intractable or not. So based on this definition of intractable, okay, like being intractable or not being intractable, okay, we are going to categorize the problems in computer science. So we are going to define, like we have three categories. First of all, we have the problems that have polynomial algorithm, and we found this polynomial time algorithm for them. So problems with polynomial time algorithm have found. Okay, so have been found. Such problems are, for example, we can mention like the sorting out problem, or search problem, or for example, minimum spanning tree, or or there are also some other like the problems that are placed in this category. So this is the first one, as we said, problems that we already found some polynomial time algorithm for them. The second categories are those that they have been proved to be intractable. So problems that have been proved to be intractable. So there are not too much like the problems in this case, but for example, one case is problems that are generated a non-polynomial amount of output. Okay, so for example, let's say problems that generate a non-polynomial amount of output. For example, these problems can provide, for example, or generate n factorial output. Okay, so those problems that generate this amount of output, then they are intractable, and they have been proven to be intractable. The problems that are undecidable, okay, and we're not going to talk about like these questions, like these kind of problems. You may see these problems in for example, the theory of computation course, okay, that talks about these problems. And so problems that are undecidable. And the third group that we're going to talk like in this week are those problems that are we don't know about their intractability yet. So no proof of intractability and no known polynomial time algorithm. So which algorithm, or which problem, problem? So we have, for example, the 0-1 knapsack problem. We have the problem in coloring graph. when m is greater than or equal to 3. We have, for example, the traveling salesperson problem, or TSP, so traveling salesperson. So these are the problems that we don't know about their intractability yet. Okay, no one so far have proved that if there exists some polynomial time for them, or nor they haven't they have proved that there aren't like the polynomial time function for them. Okay, so these are the kind of the problems that are our interest for this week, and we're gonna talk about them.